we're Team Big Mastermind Energy. Imagine being in the middle of a surgical procedure and the blood filtration device suddenly clogs. You're worried about backflow into the patient, you're worried about contaminated fluids leaking past the seal, and you're worried about the vacuum pump won't make it through the rest of the procedure because it's already half filled with blood from earlier cases. This isn't a rare scenario. In many low-resource clinics, especially the ones like we visited in Guatemala, blood filtration devices designed for single reuse are reused over and over again. Not by choice, but because they don't have replacements. Our feedback from technicians told us that clogged filters, leaks in pump failures were a constant fear. In some cases, they were worried about harming a patient right in the middle of surgery. With no other options, some clinics even tried to build their own makeshift filters using plastic Tupperware containers, bits of tubing, and pieces of t-shirts, just to keep the procedure going. In many places around the world, this isn't just a worst-case scenario. It's something clinicians face every day. This is the industry standard filter used in the clinics we visited. It's made for single use. The mesh clogs quickly, the housing can't be opened or cleaned, and after repeated cycles, the seal becomes unreliable. So when it gets reused over and over, it becomes a risk. Clogged flow, leaks, contamination, and damage to the vacuum pump.
It features a 2-layer filtration design, a stainless steel mesh for durability, a PTFE micro mesh for fine particle capture. Together, these dramatically extend the device's functional lifespan. Our threaded filters allows for clinicians to open up the device, clean each piece separately, and replace the filter and mesh baskets if needed, and reseal the whole thing back up. The separation is something that the industry filters simply cannot do. Our threads are also designed so that when you reseal them, they stay vacuum tight and allow repeated cycles. We validated this design in 3 ways. Computationally, modeling pressure drop across the mesh layers, experimentally with E. coli bacterial filtration and fluid flow over time, and clinically using a pig blood mimic setup to simulate suction during real procedures. The results were consistent. The seal held under vacuum, the flow remained steady, and it successfully survives autoclave and autoclave-like cleaning cycles. The filter layers perform reliably throughout repeated cleaning and reuse cycles. Now Aastha will show you how we built it and how it works in action.
So here's what we did. We designed our prototype with easy-to-use manufacturing methods, making sure it can be produced locally in areas that don't have a ton of resources. The housing is built from a tough, sterilizable plastic, and both mesh layers are super easy to swap out. Basically, we wanted everything to keep clinicians safe while still feeling familiar, user-friendly, and most importantly, reusable. You can also see we added a texture exterior on the housing to give the user a better grip. Plus, we used a 2-part threaded design that improves how well it seals and how many times you can reuse it. There's also a gasket between the housing and the filter to make sure the vacuum pump works efficiently. And finally, there's a basket that holds our unique 2-layer mesh filter, which is designed to last longer. So now that you've seen our prototype, you might be curious about how we actually keep it clean. In most clinical settings, they typically use an autoclave, which sterilizes equipment with specific heat and pressure. Our prototype can handle multiple autoclaves just fine. But in lower resource areas, people might just use boiling water. We tested that too, and the prototype held up perfectly after being boiled. We even tried using a pressure cooker as sort of a makeshift autoclave, and as you can see in this image, both the autoclave and the pressure cooker reach the same pressure and temperature needed to sterilize it. Next up, for our validations, let's talk about hydrophobicity. We did a test with E. coli on the industry standard filter to show it blocks bacteria in liquid, proving it's functionally equivalent to our PTFE filter in the second mesh layer. For the second validation, we did a flow rate preservation test. In the video, you'll see that after just one use, the industry control filter and our prototype both maintain a similar water suction rate. Even after autoclaving our prototype, the suction performance stayed just as good, while the industry device was not autoclaved. In that same validation, we ran multiple cycles to measure how long it took to collect 200 milliliters of liquid. On average, the industry control took about 6 seconds, while our prototype actually did it in around 4.5 seconds. For our third validation, we worked with our contacts at Ecofiltro in Guatemala. They used their pro-oximeter machine to test our unique 2-layer filter design. The results showed that the stainless steel layer helps keep the PTFE from clogging too soon, giving it a longer life. Plus, the permeability test showed a high flow rate with low suction resistance, which is great for surgeons because it means better control and less risk of backflow into the patient. From field observations to prototyping to testing, This device reflects everything we value: teamwork, innovation, and the planet impact mission of creating engineering solutions that uplift communities around the world. We're proud of how far this redesign has come, and we're even more excited for what it can become next. Thank you.